This is a continuation on the episode about wire. So the last thing we looked at in the previous part was the color codes for wire. Let's go into a little bit more detail. I showed you some graphics, but let's explain those graphics a little bit better. I think we can do a better job discussing them. The first one we're going to look at is green wire, which is ground. Ground is almost always green. If you see a green wire that's not ground, it's very unusual. European color code, you can use green with a yellow stripe. Black wire is the AC ungrounded supply voltage, which means it's the hot. And red is the ungrounded AC supply voltage that is less than the incoming voltage. Okay, let's talk about an example of that. Let's say you have a panel and it has 440 volts coming into it, and you need to have some 110 volt control voltage. Well, you send that through a transformer. Well, that means that the wire bringing the 440 into the panel is going to be black because it is the main ungrounded supply voltage. After you go through the transformer and reduce that voltage to 110 volts, that hot should then become red to identify as not the same voltage as the incoming voltage. So that's typically what we would use red wire for. If you see yellow or orange wire in a panel, beware. That signifies typically that voltage is coming from another power source outside of that panel. So if you turn the main disconnect on or the main power off going into that panel, if it's a yellow or an orange wire, it may possibly still have voltage on it coming from a different source. So always check those with a voltmeter. The other side of that is white with a yellow stripe or white with an orange stripe, and that is going to be the neutral of that extraneous voltage that is coming from another panel. You've also got blue wire, which signifies ungrounded DC control voltage, or plus. The plus voltage is blue. And then you've got blue wire with a white stripe, and that signifies the common DC voltage, which is commonly known as the negative. Neutral can be white if you're using US code, or it can be gray if you're using European code. Typically, the old DC designation for the US is for DC is red is hot and black is common. You can see this on things like cars, and well, even the meter leads for a meter are going to be red and black, and the red is typically hot and the black is typically common. Let's talk about color codes for three-phase power. Three-phase power in the United States is normally it's brown, orange, and yellow. It's easy to remember because it's BOY, boy. If there is a neutral, it will be white, and green will be ground. European color code is black, red, and blue. Black would be phase 1, red would be phase 2, blue would be phase 3. And gray would be the neutral, and green with yellow stripe would be the ground. What we normally do in the US, we will usually run black wire most of the time, and we will put colored tape on the around the wire near where it's connected with BOY, brown, orange, and yellow on it, and that's typically how we identify the three-phase power. This is probably the most important part of this entire video. It's the National Electric Code allowable ampacities of insulated conductors rated from 0 to 2000 volts. This is from the 2002 version of the National Electric Code, but it has not changed. It is still the same in 2022. If we start from the top, we will see that it tells you what material that the wire is made out of. It gives you a choice of copper or aluminum conductors. And below that it says, okay, we've got a row of the temperatures. Those temperatures tell you where it is still within the range of the wire to handle the current. The next section tells you the different types of wire. You've got everything from TW to MTW to THHN to TFFN, all types of wire. On either side, it shows you the size of the wire. And a strange thing is that the higher the number, the smaller the wire, until you get up to size 1/0 wire. After that, it changes just a little bit. Okay, the main section in this wire chart shows you the ampacity or the amp limits of each kind of wire and each size of wire. And that is located right in the center at the bottom. So let's do a pretend here. Let's do a scenario. Let's say that we know we have TFFN wire, and we know it's a copper wire, so that means we will use this column where the TFFN wire is mentioned. And let's say that we have a scenario where we've got something that is going to draw 50 amps. The first thing we do is we multiply that 50 times 1.25, and that gives us 62.5 amps. So we go to the next highest rating, which in this case would be 65 amps. And if we follow that across, we see that in the TFFN type of wire, for 65 amps, we would have to have number 6 wire. And that's how you use this chart. This shows this particular chart in its entirety. And it goes from size 14 wire all the way up to 2000 MCM wire. Now 2000 MCM can handle up to 750 amps. That's pretty good size wire. Let's talk about wire numbering systems now. When you are troubleshooting, you've got to know what wire does what. And we do this by assigning them numbers or some sort of nomenclature to let you know what they are. Every engineer almost has their own way of doing wire numbers, but there are some basic ones that pretty much everybody follows the same rules on. For example, we're going to start with DC voltage. Let's take a look at DC voltage. The identification numbers for DC are labeled according to, it first of all lets you know that it's DC. It lets you know if it's the plus or the minus on the DC, the positive or the negative. Sometimes it will show you what voltage it is. An example, some of the examples are VDC plus and VDC minus. It could be just DC plus and DC minus. That will let you know that it is DC voltage and which one is hot and which one is common. And again, sometimes we'll put the voltage on there. It could be 12 volts DC plus It could be 24 volts DC, it could be 36 volts DC, 48 volts DC, whatever the voltage is, but it is usually always marked with the DC and a plus or a minus, or just plain DC and common. In that case, the plain DC would be the hot and 24 common would be the common wire. All right, now let's take a look at AC. We're going to start with 120 volts. It could be pretty much anything, but 120 is often used as control voltage for a system. So let's take a look at the 120 volt nomenclature. It will be 120 volt hot is usually labeled X1. 120 volt neutral is X2. That is coming from a transformer. And 120 volts ground is always G or GRND or GRD or something that indicates that it is a ground. And it is, of course, normally green. Okay, now once you've dropped that voltage down, like if it comes in as X1 and X2. If it comes from a transformer, the wires that leave the transformer are called X1 and X2. After you go through a circuit breaker or a fuse or whatever circuit protection you've got, the 120 volt hot becomes 1, the 120 volt neutral becomes 2, and 120 volt ground remains ground. Sometimes we're going to use 240 volt AC. If we do that, we come up with these names. Line 1 is L1, line 2 is L2, neutral, if there is one, is labeled 2, and ground is labeled GRND. Many times ground is not labeled because green is universally known as the ground wire. However, if you do label the ground wire, it will be GRND, GRD, or G. And it will let you know that this is a ground wire and it is safe. If you're at all serious about learning about electronics, I strongly recommend that you purchase a book. It's called The Ugly Book. It's where all of my charts and references come from. It is a wealth of information, and I strongly advise you to purchase it. It's about 20 bucks, and you can buy it online, and you can get it in bookstores. You can find it most any place. But it's a really great thing to have. It's handy. It's small enough where you can put it in your toolbox, or you can put it in a place where it's easily accessible. So I highly recommend that you get one of these.